Welcome, I'm Bill Wake. We're here working on a programming language called Tenth, and we're implementing it with assembler language. And today we're going to start by implementing a string equal function, much like the one in the C library. This is kind of needed for a chain of things, but we want to be able to compare strings so we can make sure that the strings we generate from converting decimal to string are valid. And I think I'll also create a assert equals for strings. All right, so we ran, I guess, well, I cleared that off. Let's do another make. Okay, we've got these errors. cLikeTests, we've tried to address these values with ADR, but they really need to do load address. Was that in the test? Yeah. Put this next to its test. Okay. All right, so empty string, string non-empty, that stuff we already did, but we started this test and then we put it aside to deal with this one. But we'll do load address. X1 gets that. And here. Okay, so that should build. I'm not sure it's quite done, but oh. Okay, so see, like load address is in the core macros. Yeah. Let's include. I don't even know if that's. It feels a little off. Or see cLikeTests. I guess for tests we don't mind. Okay. Deck to string, string EQ. Okay. Deck to string, we're going to save that one. We set it aside. I don't know. We're not running that test. We're just running the empty string equal test. Okay, and then string equal doesn't exist, so let's make that a function. We'll do it in here and then move it over just like we often do. Okay. And let's find the prologue and the epilogue. Now we may not need to do this, but it just sort of by default we will. You only need it if you're calling other methods, and I don't think string equal is going to need that, but that's okay. All right, now we have the function, and well, okay, we're giving it two empty strings. We want it to return a 1. And that should fail. Okay, string EQ for empty strings. And this is cLikeTest.out. Let's just run that one. Okay. All right, and we return by putting a value in x0. And we'll put, I don't know if this is required, but let's make sure we are consistent. Okay, this should pass. make. Well, I guess we're going to get that. Okay, it passes. There. Okay, now let's do a little tougher test. Well, it's going to be something like this. And we'll have some more data. Let's say empty versus non-empty strings. Okay. And we'll take well, I guess we could put that data all up in there. Okay, so Xcode's a little weird on these tabs too. All right, we'll load L1 string empty. Let's load L3 non-empty. We'll call our comparison. They should come up as a 0, and that should fail if we call the test. All right, there's our fail. Okay, now we're going to start thinking. All right, so I guess we're going to be given two strings in these two variables. We can manipulate them. It's fine. Okay, now I think well, we had an example. Let's work with that. This basically does load register. It's load indirect from a register for a byte. Okay. And load an increment. Okay. So basically we're starting this at page off. That's basically our load address macro. So we're going to have a loop, and we're going to load the bytes into two temp registers and compare them, not to this, but to each other. And if they're equal, we'll keep going. And if they're not equal, we'll do an error return. Return a 0, otherwise return a 1. Okay. Okay. And so that's going to be something like this. I'm kind of indenting. I don't know. I'm trying all these little conventions. We'll say loop streq. And we're going to load bytes. Byte. And then we're using x0, x1. So let's use W2. Ooh, that's a good question. Let's see. We have that. I guess this massive manual. Well, let's just try CMP and see how far down we get. Okay. Quick link. Compare immediate. Okay, so that won't do it. Okay, so comparing a register to an immediate shifted register, that sounds more like it. Okay. So yeah, we can. Oh, but that's comparing the register. So we have to get the bytes into the register first. So I don't think we're going to escape an LDRB. But we're going to load the contents of x0 and increment by 1. Okay. And then LDRB W3 x1 increment by 1. Okay, we're allowed to destroy the pointers, so we're doing that. All right. And we're going to compare W2 and W3 branch. If they're equal, we're going to go back to, well, no, if they're not equal, I don't know. It depends how fancy you want to get on the way out. One way is we're just going to boom, boom, boom along the ways until while they're equal. Is that going to work? Not really. And if they're equal, they could be. We have to stop at the 0. Yeah. I don't know if we can be clever. I guess we don't own the space the string is in, so there's no guarantee there. So, okay, so, well, our case is empty versus not empty. All right, let's do this. Okay, so let's take that one first. Well, like you say, it's really more compare W2 pound 0 Well, it's if they're we have to do both of them though, right? Oh gosh, and you got to branch after you compare. Can't just go around comparing. Okay, because if they're both 0, then we're done. But if one of them's 0 and one of them isn't, well, we're done as well. But it seems, I don't know, maybe I should just sketch this out in real code here first. So I'm going to loop. Well, I guess the critical thing is if W2 equals 0, if it's not 0, whoops, I don't know. If W2 is not 0, we're going to skip forward. Well, no, we need to know if W2 or W3 is 0. If one is not 0 and the other is. So if W2 is 0, see, I'm wondering if I can do a final comparison when I stop the loop. W2 is the character. So if I get out of the loop from this, and they're basically, I want to compare them and If they're equal, then we got through okay, I think. Okay, so if W, oh my gosh. Well, congratulations, I guess. Yeah. I feel a little tear though, you know. It's like, but you know, making a decision then following through, that's like such a huge thing. Even something like that. Okay, I guess if it's equal, we're going to loop exit streq. Okay, and that's down here. Okay, and then we'll compare the other one. If that one's a 0, we better exit. All right, and then we compare them. If they're equal to each other, we go back to the top. Otherwise, we fall through here, and now we got to decide the situation. Well, if the characters are equal, then we exited the loop. Let's see, if they're equal, we normally continue, but if they're equal and they're 0, if they're equal when we get out, they must be 0, and therefore they were equal all the way. Okay, so compare W2 to W3 and branch. Well, let's load our return value first. Move x1 gets 1. Okay, if they're equal, exit streq. It'd be nice if I could tab and get something, but I don't. Am I backwards? If they're equal, no, I think I've moved in the answer for, should be x0, but I've moved in the answer succeeded. If they're equals, then we must have got here because we had 0, 0, and then we've done the work and do this. Otherwise, we move 0 in, and maybe you're saying this. And we have that result. Okay. Okay, I don't know, kind of a big step, but I mean, it's like one little loop. All right, so we load up the values, move forward to the next one. If they're different, return with 0. Oh, you're right. No, it's EQ. So if they're the same, we return 1. If they're different, we return 0, right? So if they're equal, we've got a 1 ready to go, and we go down here and exit. If they're different, they get here, and we change that to a 0, meaning they failed to be equal. So I think it's okay. Gosh, that's as big of a routine as I want to write, though. Oops. Okay, what's your problem? Still forgot that double colon. Okay, so I got a pass. Let me walk through again. Okay, prologue, we're not calling anybody, so we don't need the prologue or the epilogue. And I can make this there. Okay. All right. We load up the 2 bytes and move the pointers forward. We compare, if this one's 0, we're going to exit the loop and decide if they're the same. If this one's 0, we'll exit the loop, although we kind of know they're not the same. Then we'll compare the 2 characters, and if they're still equal, we'll continue the loop and move on to the next one and so on. So when we get here, it's because either we got here because the first string ended, or the second string ended, or the 2 characters aren't equal. And I don't know, it's a little, it may be, yeah, we can do that. Oh, you're flipping this comparison? So are you saying you would check line 102, move that one above line 98? I don't think that's going to work. I think if they're different, okay. Let's put one more test in. Let's make a real, well, 2 more tests, I think. Let's make, well, gosh, I almost want to do 3 more tests. I want to get everything pinned down, and then let's work on optimizing it or refactoring it. Okay. Let's make this non-empty versus empty just to make sure the symmetric aspect of it is right. Okay. I don't know. I can't quite guess how to say that. Why is fair and caker, however you want to say it. Welcome. Hello. So we're working on a programming language I'm inventing, but it's basically Forth with some tweaks. And mostly because I wanted to practice some assembly language programming, and especially to try out this technique that they call a threaded interpreter. Let's see, I'll take a moment here and explain that because it's not something you run into every day. Basically, the idea is, this one. Basically, the idea is you have 2 kinds of code. One is assembly language routines. They're just normal call the subroutine return kind of things. The second kind is, it's called a secondary, is just you give it the list of addresses of other routines and it calls them. So this is very much how Forth is. You push, pop, if this, swap that, all that kind of stuff. Many times you're calling other secondaries or you're calling primaries. And then the rest of this is kind of, the first 2 cells there are dictionary headers, name of the routine and a link to the next routine. And then this address, when we call one of these 2 things, we start by, we call whatever address is at that location that we're pointing to, and indirectly, so it then calls into the block at once. Or in this case, it calls start2d, which walks through the list and calls each one of those. So you end up with this, I guess this part's the threaded part. I'm not quite sure the vocabulary of it, but this is like this list of things to do, and some of them require other people to do it, and so we've done a few, 2 or 3 routines like this, and we've sort of done we've done one secondary test that called these routines. So we did like push 1, push 2, add, make sure we get 3. Okay. And so I believe we've got this interpreter in good shape, and I'll show that because it's so tiny. Let's see. Interpreter, where are you? There you are. Okay. So this is the code that when you call it to handle one of those secondaries with the list of things, this stuff's procedure prologue, and then it just does this loop where it goes to that, looks up the function, moves forward, and then calls that function, and then back to this. So it's just working its way through that list. The #8 moves it forward one word, and then we call it, okay, and then when it returns, we're back here and we loop to the next one. So this is 3 instructions is the heart of this thing, and then a couple prologues, and then we always set things up so the last thing in the list is an end statement, and that calls the epilogue and does the return. So yeah, it's pretty small. The inside of that is so tiny compared to what it could be. So, if most of your programming is writing lists of words and then this thing takes care of it, that's kind of nice. Yeah, we're doing TDD as well. So, and I'm kind of trying to be pretty strict. I'm willing to call Unix level services open. We'll do whatever it takes to write to a terminal, print, and so on. Exit, but I'm not willing to call C library functions. We're going to write our own versions of that where we have to. So right now we're writing string equals. And the reason we want to write string equals is we're trying to do some tests and we want to compare strings. Yeah, we're using TDD. So we're trying to do tests first on things. And it's nice it'll be nice if we can do string comparison for our test. All right. Let's see. So we're back in cLikeTests. Okay. So this test, the string, I just reversed it just to take care of that. I fully expect this to pass. Yeah. I have to call it for some reason. We have to do that up here. Okay. And I call these elaborative tests. So they're tests that I think should pass, but if they didn't pass at some point in a refactoring or some other change, I'd really like to know that happened. So, it's important to me that I have that safety net. Now I think there's 2 more functions to write. Maybe we can get by with 1, although I don't think it's symmetric enough. Okay, I keep looking at the wrong ones. That's start. Down here's our test. Okay. We want to test a pair of equal strings. Actually, I want to test a pair of not equal strings for differing strings. All right. Differing non-empty strings. Okay, so I've got a string here, string 4, same one. And then we'll make a different address. Okay. Same 2. Oops. And a different. Notice we're using ASCII Z, so we'll get null terminated. I'm going to leave off that. Well, no, I'll make it very different, just more visible. Okay. So different, I can use lstring 4 and lstring 5. And I expect not equal because they're different, 0. And then I'll just put in this next test. I call other tests that you're writing to write code, I call that generative. So you're forcing yourself to generate some new code. This one, you're working through elaborating out tests that should be okay. I identical strings. And this should be a 1. And then I'm also going to put one more test. String versus itself. Okay, and we also expect that to be a 1. All right. Okay, let's move these up. Differing, not empty, identical. And versus itself. Okay. I expect all these to pass. Yay. Okay. So that gives me some confidence. And now we can start refactoring. I don't think this catches, well, this catches the critical things I can think of for implementations even different than ours. You know, like the string one, empty versus non-empty and non-empty versus empty. I don't think our code will work either way, but I could imagine code that failed one and not the other. You could have forgotten to do one of those. So I'm doing a little extra work there, but that's okay. All right. So yeah, let's refactor. The first refactoring is we're just going to pull this over to where we want it to live, which is cLike. We may as well add this while we're here. Put the string functions up here. String EQ, string length. I suspect we'll break these files up by that category kind of thing. Okay. And input x0 points to first string, null terminated string. X1 points to second string. Output x0 is 1 if equals 0 otherwise. Keep it in mind. Okay. Make sure this still goes. Okay. Let's commit that. Implement string equal. I'm kind of happy to change it a little just to kind of see if we like where it goes. So the idea is compare these first. If we're equal, branch here. Okay, so I mean the nice thing there is, right, that's that tight loop is almost certainly going to fit in the cache, right? I suspect this will too. I don't know how big it is. The little processor cache that keeps the small group of instructions. This is a tight loop because it's in there very quickly. I don't think we can delete anything from it. Now, if it's equal, if it's 0, I don't think that's going to be legit because if they're zeros, right? Yeah, these would have to change to the opposite, but if they're equal and they're 0, we're going to keep going, and then we'll start accessing stuff outside the string. So I think we do have to do that other check first, unfortunately. Yeah, a comparer is going to compare them to each other. Yeah, I don't think we can. I don't think we can skip that 0 test first. Look, exit string equal. Sorry, you're saying the way it is now, it should be a B and E somewhere. I don't think anything should. If we'd moved it up, maybe something should have flipped. Yeah, should have been there. Compared to registers of non-equal branch. Well, if they are equal, we're going back for more, right? Oh, or I guess, are you saying? Okay, I get what you're saying, I think. So if we do this, branch not equal to exit. Okay. And then just branch to loop string EQ here. Or I guess I could flip it. Okay, if they're not equal, exit. Otherwise, if they're equal, check. If one of them is equal to 0, then exit. If it is equal to 0, exit. Otherwise, continue. So if it's not equal to 0, compare W2 to W3. So now we know they're equal. Okay. If W2 is 0, okay, I think I'm getting there. Branch loop string EQ. And we don't need this comparison anymore because we know they're equal. Okay. And maybe this should outdent like that. But I think we can combine these two, right? We could, if it's not equal to 0, the strings are equal and they're not equal to 0. Yeah, I think we could say this. Okay, because then he'll fall through, right? Okay, so let's say they're equal. they're not equal, then we would exit. They are equal, we check if there's zero. If there's zero, if they're not zero, we're going to go back for more. If they are zero, then we're done. We fall through. Do you think this is right? Well, I won't speculate. Let's run it. Whoops, jeez. Okay. I think that's better in the sense that, like you say, get this early exit if there's a difference, and then sort of a secondary exit if there's zero. Otherwise, we're looping back, and we're definitely cutting out a couple instructions and a loop and a branch. So that's cool. All right. Well, let's keep it. I don't know if to check so many times there. Okay, I did check it in. All right, return value is wrong. Okay, we're going to assume they're equal. We'll take another peek. If their default return is 1, if they are equal, then we come down here with a 1. Otherwise, they're not equal, so we come down with a 0. So I think it's okay. Have I convinced you? It's a pity. Yeah, I guess we don't know. We don't know if we fell through from the W2. Yeah, so first branch should return 1. This, you're talking this branch or this branch? Okay. Yeah, I mean, I defaulted us to 1. Compare. If they're equal, we'll take that 1 and run out with it. Otherwise, we'll move it in. Okay. Yeah, I don't know. I guess if I don't do it this way, I have to jump over something and all that stuff. So yeah, if they're different, they get a 0. If they're the same, they exited with a 1. Okay, I believe we're okay. Now let's go back to cLikeTests. All right, so all these tests, yeah, the test we were really after, well, originally, was this. And I'm going to move this down. Gosh, I'm beginning to think this should just be a totally different file. But we'll go for now. Okay, so I think, let's see, I guess I haven't put my to-do there. Use load address, we did that. Okay, 10.24.08, 02.08. A lucky coincidence. String EQ. Okay, so we did these two. Okay, now we're going to write a function to convert a decimal number to a string. I got it in cLike. Okay, so we're going to put this number there. We're going to load deck to string out. You know, I think maybe the return value should be a pointer to the string, and we should not be doing this data. I think this should be part of the solution, and we're just going to have a rule that says, you get Dexter's string. You should save that string if you want. We don't keep it around when you get back. Okay, so now. So I'm going to take this out completely. You want the decimal to string? You give me a decimal. You don't give me a string too. Okay, I'm going to branch that. And I'm going to move X1 should be it should be, yeah, I think it should be string 13. Okay. And that can go up here. Data, ASCII Z 13. That is L string 13. Okay. And then we're going to compare well, we're going to call string EQ. We got a string in X0 and a string in X1. Okay. That comes back with X0 being either 0 or 1. So compare X0 to 1. Oh no, we don't have to do that. We've got our assert. Move X1 gets 13. Nope, X1 gets, I guess I got to do a load address. No. X1 points there. We get string AQ. Now I want to do an assert that it's equal to 1. X1 gets 1 is my expected value. BL assert equals. Okay. It will need a string. I don't think it needs a leading space, but we'll have to have a test for negative and 0. I don't know if I'm going to worry about the limits. It would be legitimate too in a bigger project, I guess. All right, so we load the number into there. We call dec to string. It should come back with a string that looks like this. We'll call string EQ to make sure it is like that. We get back a 0 or 1 in X0. And we will expect to get a 1. They should be equals if they're done right. Okay, and then down here is string dec to string. Colon. And we'll just do a return. Okay, this should fail. Get in my rhythm. Yeah, we got to do a load address. X1 gets that. Oh. Did I call it assert equal? Yep. Okay, got to call that method, see if you want to see it fail. Okay. Do I need something in X0 to make sure I'm in legal memory space? I think that's going to be the problem of dec to string. It's going to return us the address of that, and he needs to load it correctly. But because it's going to be data space, he's got to do the load address thing too. Okay, why did that pass? Oh, no, it didn't. Okay, bus error. Yeah, good. All right, because we're grabbing random stuff and thinking it's a string. Okay. All right. So I think Huh. Okay, I guess we're gonna write that loop. Um, let's see. Where's go back here. Chapter 5. I think it's like chapter 9? Multiplication and division, maybe? Chapter 12, 13? Oh, that's matrix multiplication. This is floating point, I think. Yeah. Yeah, still matrix multiplication. That might be right, though. Divide example. Yeah, there we go. Yeah. Okay, so sdiv for sine div x4 equals x2 divided by x3. Okay. All right, so I guess we could put the comment in now and keep our head straight. Return a pointer to a string containing the string value of a number. Note the returned string is only valid until the next call. Move the string elsewhere if you want to retain it. Input is x0, value to convert. Unexternal. I mean, I think it's deck to strings job to get that pointer. Okay, x0 is value to point, return output, x1 pointer to null terminated string. Okay. All right. The trick I thought of, and then I found out everybody else in the world has already thought of this one, is fill it from the right. Load x0 with the output address. Well, x0, sorry, x0 is, yeah, x0 is the output address. Okay, so all right, so we got to do load address x0, x1 is ldec to string out. Okay, so x1 is that address. All right, and then we want to, I'm going to say add x1 gets x1 plus 20, well, plus 0 is the first, so plus 31 is the last. And then I think we got to do a store byte. The byte is, no. Sorry, let me look in here. Is it store byte? Yeah. Register to be transferred. Okay, so, well, you have ZXR as the 0 register. Although I think we'll do XR X X1 we don't need the shifting. Store byte X1 I guess X1 maybe this is pre well just that. Okay. Yeah, so, okay. Well, yeah, he's going to have to move it to X0, but right now X1 has the value we're converting. Or, sorry, X0 has the value we're converting. So at the end, we'll have to move the pointer to the string to X0 to get it on the way out. Although maybe we should just move X1 equals X0 and then let these calculations go on X0. Okay, so we're going to save the input to X1, and then X0 is going to be the pointers to the right output. Okay, so if you returned X1 at this point, I think you'd have an empty string. And should fail. Well, what I'm doing is I'm starting it on the right-hand side, and I'm going to fill in the modulo digits right to left. So I'm storing it in correct order. The easy way would be, in a sense, would be store it backwards. Least digit first to most significant digit last, and then do a reverse on it. But by starting on the far right of my buffer, I'm kind of avoiding that. Okay, so I think, well, this should fail, maybe without a bus error. No. Invalid operand for instruction. Okay, let's look at strb again. The register to be transferred. WT. I don't know. XN is the stack pointer or base register. Options are set the name of the oh, here we go. Oh no, that's something else. Store byte register to be transferred. That seems like it should be the byte we're storing. And then the other one is where it goes. That seems clear because it could be on the stack and it allows XP. So, what's the complaint? Invalid for instruction. Really? Oh, no, it should be ZR. There's sort of an implicit 0 register. All right. Yeah. WRX. X. Yeah, so ZR is this, it's one of the other registers. I think, I can't remember which one, if it's the link register or PC or something, but if you read it, it treats it as a 0 and then gives you a 0. So you have ZR and WZR. You might have XZR too, I'm not sure. But I'm trying to store a 0 at that byte, and then I need to, at the byte of X0. Yeah. I want it to fail. Okay, that's kind of better. Except, is it? Okay. That's got 32 bits. If we're returning X0, well, I'll change this for a moment just to make sure this isn't the issue. Probably 30 would have been a better choice. No, that's not the issue. Okay. I mean, I have 32 somethings. I don't even know what they are. This may be a machine dependent thing. Fill, repeat size bytes. Okay, good. Okay. Okay, so I'm confused. I would have thought this returned a valid pointer to the empty string. Okay, so we're going to load this string to our output, to our register 0. We're going to add 31 to it, so we're pointing to the last character of that stretch. X0 points to the next byte. Well, I think it doesn't at this point. Well, let's see. Load the address. Then I'm going to add 31 to it. So now I'm pointing to that last spot. I'm going to add a 0, store a 0 in that slot. And the X0 is still pointing at that slot. So that seems like that's right to me. Now, is something else going on here? I mean, it shouldn't care about alignment because it's byte pointers, not word pointers. Word pointers have to be aligned. Okay, so here we move 13 in. We branch to deck to string. We get back X0 is the address of somewhere in this string. We load the address for string 13, our expected value. We call string equals. Now, this is already a loaded address because we loaded it and we haven't done anything. Well, we added to it, but we haven't done anything else to it. I guess we could take this out briefly, but we kind of need it. Without add and store bytes. Yeah, that should get rid of the error. Good point. Does not. Okay, so there is something going on. Load address. Do I have to load W0? No, an address has to be 64 bits. Well, let's put the return back in. Make sure it's not something in the test. It is bus error. Okay. No, I'm gonna look at the test. X0 is 13. Okay, so that gets called and we immediately return. Then we load address. Oh, well, yeah, we got junk. Okay. I'm gonna take this out. Well, that's what I'm wondering. I mean, oh, shoot, you're right. I didn't go back to the text section. Okay, but I do think I need to load that address. Otherwise, the comparison stuff's not going to be legit. All right, but I think you're right. Oh, dear. No. All right. Well, I guess we're going to go there. Okay. Okay, starters. This is E since is that I think that doesn't mean anything because we haven't entered our routine yet. Okay, so we're going to step. That's the save. We're going to step over the add, and X0 should be 13 now. Wow. Address. Oh, it should be the address. No. Well, that's why we're screwed up. Okay. X0 gets 13. Wait, BL. Then B. Oh, I'm in the method. Am I? No, I'm in convert to positive. 3. Oh, yeah. Okay. So it loads. Well, that's not quite right, is it? BL Dexter string. Dexter string converts positive. Address BL B. FMLS. Did I forget that on the test too? No, that one's aligned. BL. That can't be a B. Well, this one makes sense. Okay. C is 13. Is that right? Hey, Buford 14, welcome. Yeah, we're doing assembler today. C is 12. Why is that? Okay, let me run it again. I think I'm... Okay. Store that. That makes sense. Add X0. Do you think? Oh, it's add relative or address relative. So 12 gets us to 7 something. I guess whatever, that gets us to XC. But then I don't relate to this BLO print. And we're not doing a print. BL deck to string. And then branch plus 48. Something's, we're not where I think we are. Start plus 808. Converts positive. That seems right. But plus 812, 808, it's a little bit different. ADR X0 pound XC. Well, maybe I'm the one doing the wrong thing. If I want to... Wait a minute. That just doesn't seem... I'm going to continue. Bad something. Long 3. I think their disassembler's a little bit funny, but yeah, something's odd. Okay, let me do let's rebuild this thing. Okay, dot slash lead alike. Oh. Oh, that's better. Okay. Okay, I don't know if I missed a build somewhere, I guess. All right. And we're still doing nothing, right? Oh, we loaded an address. Okay, that's something. Okay, load 13, call deck to string. Load the address x1, gets the pointer to the expected value. Move a 1 for the expected assert equals. Okay. Now, load address of that to SCR out. Okay. I think that's saying string equals said they were the same. Whoops. Gotta look at the right one. Well, no, string equals said they're different. Okay, they are different. This probably gets filled by zeros, so that shouldn't matter. Okay. All right, now I'm going to change my address. I'm not writing anything yet. I'm just adding to my return values a little different point in my fill. Okay, should be a fail in the same way. Okay. Now I'm going to store byte 0 into this location. I believe it's already that, so this should feel the same way. Good. Okay. It's been a while since I did assembly, but you know, in regular code, you're used to looking at it and you know exactly what the semantics are and which thing was there and everything. And that I'm just off myself here. Okay, so now we have the output in the last byte. We're returning that byte, and so we want to, well, at some point, to get one digit, we got to do sdiv, and let's say xw2, was it? How did that work? It was here. Oh, we can do x2. Okay. We can do x's. Although I think W is fine. Well, let's do X. X2 equals X1 divided by 10. I may not be able to do this instruction. Okay. Where does it put? Okay. Okay. And then there is no modulo operator. I do remember reading that. So we have to calculate our own. So right now we've got the number divided by 10. And we're going to take X2. Let's keep track of it. X2 equals X1 slash 10. Okay. Now we're going to do multiply. X3 is X2 times 10. Okay. And then we take, well, let's put it in X3. We're going to say sub X3 gets, X2 has to be bigger because it may have had more modulo. So X2 minus X3. All right. Okay, so we take the number divided by 10. X3 equals X2 minus X3, i.e. X1 mod 10. Okay, and now I'm going to add well, I'm going to take X3 is X3 plus X30, X3 equals X3 plus 0. Okay, ASCII 0. I guess I could put single quotes just to be C-like. Okay, and now I can store that byte X3 in X0 minus 1. Bang. Okay, if I've done this right, we should be different, but I think we'd see it's a 3. Oh. Unrecognized mnemonic. sdiv. Oh, I don't know if you can divide. Single divide, sign divide. Okay. Doesn't look like you have an immediate one. Oy. Okay. Let's move X4 is 10. I don't want to use X10 because it's reserved for something else. X4. Okay. Yeah, I'm gonna have to get it into 0 somehow. X0. Well, X0 is pointing now. We should have written the 3. Okay, so 13 divided by 10 is 10. Divided by 10 is 1. And then times 10 is 10. So 13 minus 10 is 3, plus ASCII 0 should be, well, 51, which is ASCII 3. We're going to store that 51 at the pre-incremented version of x0, so the previous character, and leave it decremented. Okay, so we're going to work our way from right to left. So I think the string we get back is the already correctly in x0, but we're just going to get a 3 with this code. Now, if I did it again, maybe we'll do this, just sort of a really stupid way to pass. Okay, now I have to move x1, right? Move x1 equals x2. So something's funny there. I'm moving too much, but I've got to get x1 being the number to convert. Okay, with whatever string we have. So x1 gets x4. Now, we had well, that's division, multiplication, mul. And we're multiply negative, okay. X4 is x2 times x3, okay. There we go. Okay. So my hope is this works. I guess I'm not quite willing to bet. Ugh. Invalid operand for instructions. Oh, really? We have no pre-decrement mode on... Okay, where was strb? Comma this. Well, what's going on? What is M? Extend M. Okay. What was the complaint? strb. Okay. At least get the instructions, and then maybe it'll... Oh, jeez. Oh, I didn't take them out. Yeah, it's funny to me... I gotta say x0. It's funny to me you can't use these modes consistently across lots of places. One of the early assemblers I worked on was PDP-11, and that thing was... They were just so regular across everything. You had access to pre-increment and post-decrement on everything. You could use it on the stack. You could use it on the program counter. Used it anywhere. That was nice. Okay, am I still 162, 163? Okay. Oh. These have to be W's. To store bytes. Okay, fail. Now I'm discouraged. All right. Oh, at the end, no, x0 points to the thing. And that's our return value. All right, I think I'm ready to debug it. We store 0. We store. So for a 2-digit number, this should theoretically work if it's positive. Okay, x1 holds the original x0. Let's make sure I'm not working on the wrong thing. I'm writing, this holds the original address. I add 31 to get to the far right. I zero out the first byte. Then I decrease and zero, copy in the next one. Okay. Yeah, let's do a make, LLDB. Okay, and I want to break. I guess I want to break like here. No, I guess I want to break here. Yeah, right after the deck to stir. Okay. Break, set, breakpoint, do this. Okay. String. I just can't relate this to what I'm seeing. All right, let's do our dump thing. Okay, we want deck to stir. After EQ. Store x30 address print branch FMLS. What is this? Is my label in the wrong place? Oh, okay. Yeah, there's a lot going on in that test assert start thing. Okay. So I need to step forward a few. Move x1, x0. I'm in Sterling. Step out. F. X1, x0. Lot byte. Step out of string length. I don't think he's moving. Yeah, that's coded in start. Well, I don't know what we're comparing at this point. I've gotten too far, I think. I don't want to run this. Maybe I can break here. Well, you're so much smarter than me. Okay, let's do that. After this, right here. Okay, stop. Okay. Break set minus b. Stop. Run. Okay, that's a load address. Good. Okay, so x0, and then okay, so that's a pointer. I forget how to do memory. Did I write it in? No. I thought I took notes the other day. No. Nope. Okay. Now I would think I could just give it, okay, I can just give it address expression and address expression. Okay. Let's look at x0. Mem read this and 4. Well, aren't you special? 4 O F F. Okay. Stretch this out a little. Well, that's kind of what we're returning right now. 3027. Now, if 30 is, well, we want a 1. Is it 13? Three's, oh yeah, wait, 3's 0, isn't it? I don't think it's 13. Whatever it is. Well, it's trying to be something, and it's 2 bytes long, and it's got a 0, so that's a good thing. And it's certainly not equal, so I don't blame our test for rejecting it. But it means I'm not doing something right when I add. Now, 1, 2, 3, these don't even make sense if they're hex. 2 times 16 is 32, 39. I don't know what that is. 3 times 16 is 48. That's the 0. All right. Something's off. Okay. Now maybe I do need to break index to string and watch these things. If they don't have the values I expect. No. X0 returns the address of the string. So reg read X0. That gives us the 404C. So it's starting to read the memory there. You know, it's the pointer. So here's the first byte. Here's the second byte. Here's the 0 terminated. Okay. If they were even like two away, right? Because 1 and 3 are the 2 digits. They ought to be 2 apart. So I think, yeah, it's not 13. I guess it's 0 prime. That's what they're claiming. Well, I guess let's look at this. Let's break here. Well, I can break in dec to string. It's not that big. Okay. Break set dec to string. Okay, and I'll run again. Okay, so we're in the test. Let's continue. Okay, we're in, I don't know why it doesn't call it dex to string, but load something BL. No. Oh, wait, here we were in dec to string. Here we're in stop. I don't know. Move, add P. That was before. Okay, let's run again. Okay, are we in dec to string? I thought I had a break in the test. Okay, move flex1, add P. So it's 2 moves, a load address. Okay. Okay, we're going to add x0, 31. Reg read x0 should be related to that. Okay, there we go. So 404F is byte 31, I guess. Okay. Now we're going to do a step, and let's look at x2. Well, let's do several. Read x1, reg read x2. Okay, so x2 should be the result of the division. So that should be a what? X1 is 13. Right, x2 is 1. Okay, that's what we want. We want it to divide by 10. All right, and then we multiply, and then we subtract. Okay, so now reg read x2 should be 1. Reg read x3 should be 3. Minus 3. Did I subtract in the wrong order? Apparently I did. Why? X2 is going to be 1. X3 is going to be 10. Oh, I got to subtract it from x0, right? Or something. I'm subtracting it from the wrong thing. X2 is 1 at this point. X3 is 10 because it's 10 times x2. But I need to subtract it from x0. And then we got to, well, no, I got to subtract it from x1. but then I got to modify x1 equals x2. Yeah, that seems right. Okay. Let's do it in both places. Sub x1, x1. Okay. Well, let's take a break. We'll check this in. Dec to string for positive numbers of 2 digits. All right. 3 or 4 minutes, and we'll come back and finish dec to string. Welcome back. All right. I'm going to try a little refactoring. Okay, so I want to say this loop starting, I think here to here should be the loop. Okay, we preload the x0. We're subtracting it as we go. And so I'm going to make this be L dec to stir loop. All right, and I'll indent these. Okay, now x1 is one. It's the div 10 value every time through the loop. So when we get back here, x1, I mean the first time through, x1 starts out 13. It ends up being 1 because that's what was in x2. x1 div 10 or mod slash 10. Yeah, div. Okay. And so I want to compare x1 to 0. I think I can do it this way. And if it's not equal, then I want to go back to the loop. Okay, so when we finish, x1 should be 0. If it's 0, we escape. If it's not 0, we go back and try for more. All right. And I think this is going to still work. It's sort of the opposite of loop unrolling. Make that. Good. Okay, now we're going to try, I'm just going to update the test to a little trickier value. And 70113. Okay, and this is 70113. All right, if those worked and my loop's good, this should work. Do a save. I'm very bad about that. Make. Expect a compatible register or logical immediate. Well, let's look at the move instruction. Should be in part C. Loads and stores. I don't think move is so different. Sold, hosts, and stores. No, I don't think there is. Well, we haven't dealt with zero or negative, but for the positives, I think we're just okay. If it's the other way, then you got to worry about, are you too big? So I guess we're off the hook on that one. Okay, all kinds of crazy loads. Your vector arithmetic machine. Compare. And we do move. I think in some ways it's a... Okay, what do we got? Oh, 16-bit. Yeah. Where's wide immediate? Okay, well, let's pick one that's 16 bits. Let's go, well, I'm curious. I'm not quite sure. I guess that should be zeroed out on the other 48 bits. So it should be the positive value. I don't know if I changed everything enough. Okay. Yeah, so that's good. No, I think it's really just that this, they're calling it wide, but it's only 16-bit immediate value or negated. So that just doesn't do it. The value of the other bits in the destination, the optional shift amount can be a multiple of 16. Yeah, we could make it bigger, but not. It would still be zeroed on the side. That's okay. I mean, I think if this is convincing enough to me. Okay, so let's move this to cLike. Let's take this too. Interesting. Oh, I hate this. Like, why can't you leave my tabs alone when you're pasting? Okay. And then I'm trying it this way. I don't know if that's a good thing or not. A lot of assembly code is just written like label in column 1, instruction in tab stop 1. Okay. We need an extern. Global. I'm gonna, I guess it's okay to use that. We won't make a word out of it because it's kind of private, but okay. So hopefully this has worked. Okay. All right. Oh, deck to string for positive numbers. Okay. Next test. Well, let's do 0 for and I think it's easiest to just exit early if it's 0. Well, I think we'll see what it does now, but move x0, 0, dex is string, load address. This should be positive. This might actually work. X0 gets 0, deck to string. We'll load the address of string 0, compare that. This should be equal. Okay. Deck to string. Okay. That's the 65535. L string positive, L string 0. Okay. Let's make sure if this works or not. Yeah, that's what I'm thinking. And if it had written it as a while loop instead of a repeat, then it might not. Okay, but you got to run the test. Convert 0 pass. Good. Okay. Yeah. So we did that right. All right. Now, let's make a negative. There's like a move negative. There's an immediate that can be encoded. Okay. Yeah. All right. Let's move negative. Move not. It's not going to be. Well, I guess we could just do. Oh, sub didn't like that. There's got to be a negate instruction. Neg. Negate to register. Okay. Let's move. Yeah, we can do this one. Neg x0 gets x0 neg, right? Yep. Okay. And then we'll deck to string, and we should get L string negative, which doesn't exist. And they should be equal. Okay. Oh boy, I'd like to get this print num ready so we could get these things printed. Oops. Oh. Okay, I think this test should fail. not blow up, but just fail if I call it. Good. All right. I think we're going to have to keep track of that minus sign because we're filling in the digits right to left. So we don't know where to put the minus sign until we get to the end. So, but yeah, we'll just keep track of that. All right. So see, like now, I don't know if this is, I feel like this could be done better too, but all right. So we got X1 and then I don't know if there's a signum kind of thing. That'd be handy. This is all over the place. Yeah. Well, there's going to be a compare, right? Oh, somewhere I saw the list of register things. Did I put that here? Ha. 144. C1, 144. Here we go. Okay. Oh yeah, minus or plus. Okay. This is almost like a constant. I can move that up. All right. Now I'm going to do CMP X1 0. I guess I'm going to start X5. Maybe I'll move this down too. So again, I got to do this. The easiest way is to do this thing where you pre-store the answer. So let's move X5. A lot of registers here. Let's say it is not signed. And then branch if it's plus, meaning positive or 0, to L no sign. Oh no, if it's minus to L had sign. Okay. We'll move X5 gets 1, meaning it had a sign. Okay, so I think I'm going to start filling in this process stuff. X1 is the original, current value or value remaining to convert. I think that's the accurate way to say it. X2 Well, no, we want to say x0. X0 is the pointer to result. Working right to left. I think that's helpful. Okay, x2 is value divided by 10. X3 is well, it's really value mod 10 calculated there, converted to ASCII. X4 is constant 10. X5 is 1 if negative. I got that wrong here. Had to sign it. Yeah, 1 if negative, 0 if greater than or equal to 0. Okay. All right, so when we get to the end, if that is 1, compare x5 to 1. All right. If it's equal to 1, no, if it's not equal to 1, then L dectuster end. If it's equal to 1, then we want to do this. We subtract 1, and then we want to write W3. We got to move. We can't write a literal. Okay, so move W3 gets pound yeah, let's see. If it's minus, right, sorry. Okay, x5, if x1, oh no, I guess that is part of that. Okay, if x1 is 0, compare x1 to 0. If it's positive, skip, okay, in which case x5 has 0. If it's not positive, it's negative, then move 1. So the sign is set. Yeah, thank you. 45 is sorry, OX45 or maybe octal. decimal to 45. Okay. I think I'll keep it. Okay. Compare. Oh, we can't compare literals? That really sucks. We do it right there. Compare x. Line 145. X1 pound 1. Oh yeah. X5, right? Is our sign. Okay, thank you. If it's not equal to a 1, then we skip. All right. Oh. Now, eventually, well, we can do it in our test just to be something. Converts negative dec to string. We could say print. I think. This print is X. Here's the address. Okay, yeah. So let's use our tool to tell us what it's got. Segmentation fault. Wait a minute. Converts negative. Star plus plus dash plus. What does that mean? X is the address of an alternated string. Huh. So no, I did not. Good catch. Or did I? Nope. We even looked up the value. Neg x5 equals x5. Oh, no, not x5. X. Zero. Gets the value coming in. Then we're going to move it to x1 to work with because x0 is going to become our target. Okay, I think that's better. No. X1. Well, X. No, because we're doing this here. Because we're saving X1 to work with. We're going to work with it in X1. So x0 at the start is the, oh, sorry. Now I see what you're talking about. Okay. I guess I moved that down and got myself in trouble. Maybe this should be above here. Like x1's kind of the working value, so let's go off that. x5 is the sign. Okay. I guess I want this above that too. Is it that? Oh, it still changes the tab. I think it just doesn't know this is code for some reason. All right. Move the sign flag, gets a 0. If our new current number is compared to 0, then flip our current number. Okay. All right, good. Nice catch. Now, something, I guess our test could print out a name. Let's see. Make sure I've saved everything. Run this, ACP, make deck to string work for 0 and negative. Okay. Whoa. All right. So I think what I want to do is just sort of a housekeeping thing in our test. Okay, I'm going to put some data. Well, this seems like something a macro could do. There's no harm in that part, just to make sure. Okay. Oh gosh. I don't need to, oh. Whoa. Line 13572. Okay, whoops. I guess I just saw the passes. That's terrible. At least the number looks right, but something's going wrong. Well, no, it shouldn't be missing. We put the terminator in first, so okay, so this writes our terminator into the last position. So we started at 31, we wrote the terminator right away. Down here, x0 is updating as it writes them. I mean, because we're seeing the right value, x0 there. So it's not a 0 thing. Yeah, so it's odd. I mean, before it was getting the wrong value printed. Okay, so let's look at cLikeTests out. I think if we run, we'll see better where it's blowing up. Bad access in string length. Yeah, in our code we were doing pre-decrements. I was trying to do them by the with the memory, the mode with the pre-decrement inside here, but it doesn't do that for strb for who knows why. So we keep subtracting the address, take away one, and write to it. So when you return, when you return x0 should be the right address. All right, so I guess let's look at the registers. X0. No, that's not good. Why would string length plus 32? Okay, I guess we got to go down. Let's dump this again. String length. String length plus 32, that's plus move x0 pound 0. Okay, let's see string length. Oh, that's print string length's up here. Move x0 pound 1 pound 0. Oh, I think I destroyed the value by throwing that in the test. Converts negative. Right, because x0 had the address of the value, but we don't return anything from print. So I think it's just me throwing it in and saying I did it because I was going to ignore the rest of this, but then I got caught up in what was going on. Okay, yeah, there we go. Yeah, another bad check-in fixed. Okay, remove debugging code that caused a seg fault. Okay, I'm going to take, we just have a few minutes, so I think, I don't think we're going to get print none done in 7 minutes. So I think we can get done is a macro for start all tests or something like that. We got test start, but let's make an all start or something. Test all, test name, and yeah. Okay. And so I want to put, well, I don't mind doing the data thing. Dot data dot ASCII backslash test. Well, this is really like file name. Dot text dot b2 line 2. Okay. And then I just want to do a branch No, I want to load address x0 gets L test all name okay. I think I can do backslash n field print and then go on as you were. Okay. I don't think he knows about I don't know. This is core.macros. I think it's becoming more like a bare minimum, or just like helpers for working with the assembly language, and not anything more. Okay, and then makefile needs to know that. Macros. Okay. And then it does. I want to be able to say test all. Okay. Boom. Oh, load address is already defined. This is where I'm. Core.macros. Which one am I building? Core tests. Interpreter tests. I'm probably not doing this very well. Okay. Did it print what I wanted? Oh, that's not a backslash. Okay, there we go. cLikeTests. All right. Yeah, I think. Yeah, let's put that for review next time. In the to do. Okay, deck to string is done. Work out scheme for dependencies on macros. Is core dot macros needed everywhere? Okay. All right. So I think that gives me the bare minimum. I'll do the rest offline, but I'll just put in the test all calls for the two files, and the blank line before will separate out the blocks of these a little bit, and I'll check that in. But thanks for this week. I'm so happy we got the interpreter core done, and I think the stuff around the edges here. We're getting these prints, and we'll get an assert string kind of thing. This feels like we're kind of poised to just begin to just fill in capabilities. I think the core of what we're doing is there now. There may be some refactoring on some of that, but I think the core is there. So looking forward to next week. I think, let's see, I know I'm traveling in February. I guess I'll be here next week, but the week after it's going to be a short week for me. All right. Thanks for joining, and take care and have a good night and a good weekend. See you Monday, 2 to 4:30 or 7 to 9:30. Thanks.